Hari Om students, I hope you all are doing well and we are going to continue the chapter friction, and I hope you are able to understand all the concepts that we have done through this online classes. So, in the previous class, we understood the meaning of friction, why the friction takes place, what are the advantages and disadvantages of friction. Means overall we understood somewhere we need high friction, somewhere we need low friction, and if we need high friction we know how to increase the friction, if we need low friction we know how to reduce the friction. So both are equally important in our life, and till now whatever friction we understood, that is totally based on the friction with the solid surface. So in the previous classes we understood any two objects which are solid, they are moving against each other, they will have friction between the two, and that was given the name friction only. But it is also possible that if you are moving in the atmosphere, within the atmosphere air molecules are also giving you some friction. If you are within the water, if you are swimming in the water, within the water, then the water is also going to give you friction. So that is the topic we have today, that is even the fluid can give you friction, and we'll see what are the different types of the fluid friction, and we'll complete the topic today. So very first thing we are going to learn is friction by fluid. Okay, so in general, if any object we have, that object can move in the atmosphere, so it will be surrounded by lots of particles in the atmosphere, we can say air molecules we have, and the same object can be placed within the water. So if the object is placed within the water and if it is moving within the water, then also it will get friction by the water. So in general, the air, the water or any fluid is capable to give friction to any other object, and that is called drag friction. So in general, the friction given by fluid to any object is called drag friction. The name is given, and this friction can take place between any two layers of liquid or fluid, we can say, or it can take place between fluid and solid object. So very first, the fluid can also give the friction, and that friction is given the name drag. Now this friction can be between any two layers of the liquid. For example, if we have the liquid, now even in the liquid we have different layers. So just imagine we have different layers of the same liquid. So let's the layer is X and Y. So even between X and Y there is some relative motion, because the molecules are always moving. So we can say different layers of the fluid are in motion, and because of the relative motion between the layers of the fluid, they will also have friction between the two. So even two different layers of the gas or the water or any other liquid can have the friction, and that friction is called drag friction. So this is one thing which is possible. It can be between two layers of the liquid or the fluid, or it can be between the object and the liquid. Means if any solid object is placed in the water, if the solid object is in the air and if it is in motion, means the object is in motion or relative motion with respect to the water, with respect to the air, or with respect to the fluid, in that case it will also get the friction by the fluid, that is called drag friction. So overall the concept is, if any object is in motion or relative motion with respect to the fluid, then the object will get friction by the fluid, and that friction is called drag friction. So, and this friction can take place between any two layers of the same fluid. It can take place between the fluid and the solid object. So we are going to discuss today how the friction or the drag friction will take place on the solid object when it is moving in the fluid. So it can be air, it can be water. So I hope this much is clear. And the statement you can write down yourself. If any object is moving within the fluid will give the friction to the object, and that friction is called drag friction. And this friction can be in two ways. So I hope this is understood. So the topic we have today is drag friction. So I hope this much is understood, and definition you can write down yourself based on the understanding. Now in general there are two different types of the drag friction. So two different types we have that we are going to learn, and the very first is called pressure drag, and second is called skin drag. So we will understand the meaning one by one, that is pressure drag or skin drag. What is the meaning of both with the help of some example, and it will help you to understand the concept. So let's start one by one. That is the very first, pressure drag. So we can write down the next topic we have, that is pressure drag. So just take an example. This is the object, and now this object is moving in the air. So we can take the example of the air or the liquid. So let's understand with the help of the air, and same thing will happen in the liquid also. So if this object is moving in the air or in the atmosphere, so if it is moving in this direction, so what will happen, more and more air molecules will come on this face. So when it is moving forward, the air in front of this will be compressed, because when it will move front, it will take more and more molecules with each other, means the air molecules will be compressed together at this point. So air molecules will give some pressure on the front, and whatever pressure will be given to this front, it will basically oppose the motion of the object. So you know, when you are moving in the atmosphere, when you are running in the atmosphere, sometimes you feel that air is coming on your face, and that is basically creating a problem for you. So when you are trying to move against the wind, it is giving you lots of disturbance, lots of resistance to move forward, and that resistance is called drag or pressure drag. So simple concept is, if any object is moving forward, so air molecules will be compressed here, and whatever pressure will be given by the air on this face, front face, will oppose the motion of this object, and that is given the name pressure drag. So simply we can draw the diagram. So if any object is in motion, so the air will be compressed here. So on this face there will be pressure on the object, and that pressure is given the name pressure drag, that will oppose the motion of this object. And you know, when you are cycling, sometimes you feel like it's difficult to do the cycling when you have lots of air coming in your front, because you have to overcome that force given by the air, and that is nothing but the pressure drag, that is also going to oppose the motion or resist the motion of your body. So we can say that is the pressure on the face of moving object by air molecules which resist the motion. Okay, that is called pressure drag. So I hope this is understood. So just remember this concept. This will help you to relate with the concept that we are going to discuss very soon. And Why this basically takes place, we can also try to understand the concept. Why this pressure drag comes in contact. So we can say if object is moving in this direction, there is a friction taking place in opposite direction, that is called pressure drag. So how this friction will take place, let's see more explanation of the same concept. So in general, when the object is moving in this direction, what will happen, the molecules here will get compressed. So air molecules will be compressed here. Compressed, you know, if you move this marker in front, so whatever molecules are there in front of this marker will be brought together and the air will be compressed at the one of the space. So in the front of the object, the air molecules will get compressed. So we can say here we have high density of air now. So when the object will move front, air will get compressed, and because of this the density will become high. So we know if the density is high, we will have high pressure also. We have done in the previous chapter. So pressure is high. We know more density, more pressure, low density, less pressure. So in the front, now pressure become high. So let this pressure be P1. So at the face, the pressure by the air is P1, but at another point at the backward P2, the air molecules are still far away. So at this point air molecules are far away. So here we have less pressure. Why? Less density, less pressure. So we can say P1 is greater than P2. So P1 is high, P2 is low, and you know, if any object is placed between high and low pressure, the object get a force that is from high to low. That is why it is getting a friction in the backward direction. So since at this point we have high pressure, this point we have low pressure or less pressure, a force will start acting opposite to the direction of motion. That is because of difference in the pressure high to low. We have done lots of activity also in the previous chapter. You have seen the water rising in the container. So within the container the pressure was low, and outside the container pressure was high, so water was moving from high to low. Why? Because a force was given to the water, and that is always in the direction from high to low pressure. So because of this concept, whenever you are trying to move in the atmosphere, air gets compressed, and because of that the pressure becomes high in front. At the back the pressure is low, and because of the difference in the pressure you start getting a backward force which basically opposes your motion, and that force is given the name friction. That is nothing but pressure drag. So I hope you understood the concept. Okay, so things are related. We are going for the next. So overall, the drag is just because of the molecules. So molecules basically interact with each other. So we'll talk about that later on. Now let's go for the next type of the pressure we have, or the drag we have, sorry. That is skin drag. So let's understand again with the help of this example. So when this object is moving in front, this face is getting the drag, that is pressure drag, we understood. But the air molecules will also pass over this surface from all direction. So air will pass from this surface, and when the air will pass through this surface, it will also give friction to the side surface of the object, and that is the name given skin drag. So we can say if an object is moving in the air or in water, it will get one friction in the front face, that is pressure drag, and the other friction will be sidewise, that is because of the molecules which are passing through the surface from the side surface, and that is given the name skin drag. So the concept is the same object. If you draw again, the object is in motion in one direction, so the air molecules will pass through the surface. So I am showing you air molecules. So between this air molecule and the object, the friction will take place, and this friction is given the name skin drag. So skin drag is also in the opposite direction, that is opposite to the motion, that will always try to oppose the motion of the object. So why it takes place we'll discuss, but very first we should write down meaning. That is, the molecules of fluid. So I'm taking the example of air, but same thing will happen in the liquid also. So in general, fluid, we can say the molecules of fluid which are passing through the side surface of the object that is in motion give skin drag, or we can say give friction called skin drag. So I hope this is understood. Drag friction. Another type we have skin drag. So if any object is moving in the liquid or in the air or any fluid, then the molecules which are passing through the surface of the object, that is from the side surface, it will also try to oppose the motion of the object. So it will give the friction that will be opposite to the motion of the object, and this friction between the object and the fluid in the sidewise surface is called skin drag. So this is the difference we have. Now let's understand why will it take place. So we know any surface is not 100% smooth. So any object that we draw, it will have some irregularities. So I am drawing the same object. Now it will have lots of irregularities, that is on the side surface. Now take an example, this object is moving in one direction, so it is moving in this direction, motion. Now once it will move, air molecules will come. So the air molecules will try to fill the irregularities of the surface. So the air molecules, few air molecules we can say, that will come within the irregularities of the surface, and once these molecules will come within the irregularities or the roughness of the surface, these air molecules will come to rest. So we can say the object will first bring the molecules of the air or the liquid at rest. So whatever dots you see, these are the molecules which are finally at rest because of the irregularities of the surface. So we can say these molecules have filled the irregularities of the surface from the side. Okay. Now once these irregularities are filled, next air molecules will also come. So again air molecules are coming because the object is moving in one direction, so air will keep coming one side. And since all the irregularities are filled, now air molecules will not get into the irregularities, but what will happen now? Now this air which is coming is also having nothing but lots of molecules. So these molecules are at rest and these molecules are in motion, air molecules. Which direction? This direction. Now just imagine there is one molecule A which is in motion and another molecule B which is at rest. So both are air molecules. Okay, I am showing you the big picture so that you can understand. Now once A and B will come together, they will try to interact with each other. So between A and B, a force will take place, molecular force we can say. And because of this molecular force between the molecules at rest, that is air molecules, and the molecules which are in motion, what will happen? The force will take place, the bonding will take place, or molecular force will take place. And once these air molecules and the molecules at rest will have interlocking, we can say, a bonding together, what will happen? A force will start acting between the two, and this force is nothing but the friction called skin friction or skin friction drag. I am repeating again. Once the object will move in a direction, the object will have lots of irregularities on the surface from the side. All those irregularities will be filled by the air molecules or maybe the liquid molecules if it is in the liquid. Now, so most of the molecules of the air will come at rest because they will come within the irregularities of the surface. So we can say the object and the air will start moving together. So air molecules are at rest. Now other molecules will also start coming. Now since the irregularities are already filled by the air molecules, so the air molecules which are at rest, Now they will start interacting with the air molecules which are in motion. So a force will start acting, that is molecular force, between the air molecules in motion and the air molecules at rest within the surface of the object, and because of these two the friction will start taking place. So we can say it will start opposing the motion. So it is something like you are trying to move and someone is trying to hold you from the side. So if someone is holding you from the side, it is difficult to move forward. So between these two surfaces we have, that is between the fluid and between the object, there is a friction. So the concept is, if this is moving in front, between this object and the air molecules over the surface, the friction will start taking place, that is called skin drag. So we can say the molecular force is responsible for it. So molecular force between, we can say, molecules of fluid at rest within irregularities of object in motion and the molecules of fluid in motion. Okay, so molecular force between molecules of fluid at rest, that is I am talking about B, and molecules of the fluid in motion, that is I am talking about A. So these two are having molecular force that is finally oppose the motion of the object, and that is called skin drag. So I hope this you also understood. So two different types of the drag, I hope it is clear to everyone, but still any doubt just write down, we can discuss in the live session. Okay, because this time I cannot take the doubts from you. Now let's move to the next topic, that is factors affecting drag friction. So how the drag friction will increase or decrease, what are the different factors we have, let's understand this one by one. So the very first factor we have is density of fluid. So it is understood, if we have liquid in one container and the molecules are quite far away, so let this liquid or fluid be one A and another fluid B in which the molecules are very close to each other. So we can show many dots. So here we have high density, here we have low density. Yes or no? So the molecules are very close, density is high, molecules are far away, density is low. Now if any object is moving within B and within A, it will not get same drag. Why? It is understood, if the density of the fluid is high, then more are the number of molecules of the fluid, and if more will be the molecules of the fluid, more will be the resistance, more will be the friction. Why? Because more and more molecules will start interacting with the object. Because overall the drag friction is just because of the molecules. So if the molecules will increase at a place, the friction or the drag friction will increase. If the molecules will decrease, the drag friction will decrease. So that is how density will decide the drag friction. So we can say more is density of fluid, more will be the drag. So even in short we write drag friction or drag, both can be written here. So I hope this is understood. A is having fluid, B is also having fluid. A is having fluid with high density, low density, and B with the fluid of high density. So if anything is moving in B, it will have more friction, more drag as compared to A. So I hope this is understood. Number one, density of the fluid will decide the amount of drag that will take place. Number 2 is the speed of object. So if we have the fluid, now I'm just showing the diagram. So this is the fluid. This fluid can be air or water, anything. So we have different layers, and within this the object is trying to move in one of the direction. So this object, when it is in motion with respect to the fluid, it will have some speed, okay. And in general, you know, if the speed will be very high, then every time it will get more and more number of molecules. So if you are moving with a very high speed, at this point A, it will get some molecules of the air. When it will move to B, it will get more molecules. If you move to C, you get another molecules. So if your speed is very high, then in very less time you are getting more and more molecules of the fluid. And you know, if you are getting more and more molecules of the fluid, what will happen? The drag will increase. So overall your speed should be not so high in the fluid, in the air or in the water, otherwise you will have difficulty in moving. So you know, if you are swimming very fast in the water, you will get tired very soon. Why? Because when you are swimming with a very high speed, then you are having more and more drag. Same thing if you are cycling with a very high speed in the atmosphere, in the air, you also get tired in a very less time because you have more and more drag given by the air. So your speed should not be very high. So we can say more is the speed of object, more will be the drag. Okay, so I hope you understood. Second thing that will decide the drag is the speed of the object. I hope this is also clear. So the concept is, more is the speed, more and more molecules of the fluid will interact with you, and more will be the friction between the fluid and the object. Number 3 is the surface area of object in contact with fluid. So third thing is surface area. So you know, surface area is this outer area that we have. So if you have lots of area, what will happen? More and more surface will be there, and more is the surface, more will be the air molecules that will pass through it. More is the number of molecules, more will be the bonding that will be taking place between the molecules. So you understood, the drag will increase. So to move a heavy object or a big object in the atmosphere is quite difficult, and to move a small object is not so difficult. Why? Once you increase the dimension or the size of the object, the outer surface will increase, and more is the outer surface, more will be the friction or the drag between the molecules of the fluid and the object. So it is understood, if I try to move this bulb, this much is the area of surface in contact with the fluid. So this will decide how much will be the friction between the fluid and the object. If I move this way, the bulb in front facing this area, then it is understood, more is the front area, more will be the drag, that is pressure drag. If you move the bulb in opposite direction, what will happen? The front pressure will decrease somewhere, so it is understood, the pressure drag will be less, so friction can reduce somewhere. So even this is another possibility we have. We can move the object this way and the other way. In both the case, the drag will be different, and it is understood, more is the front area, more will be the drag, less is the front area, less will be the drag, because in both the case somewhere the outer surface is same somewhere. Okay, if you are trying to move the knife in the atmosphere or in the water, you know, it's not so difficult because the front area is almost negligible, so the pressure drag will be almost negligible. So the maximum pressure will be the maximum friction or the drag will be skin and not the pressure drag. So if we can either decrease the pressure drag, we can either increase the skin drag, and if we can increase or decrease both, then all things can change. Means by changing the front face, by changing the side face surface, we can bring a change in the drag. So you understood, less is the front area, less will be the pressure drag, and it is quite easy to move the sharp object in the atmosphere. But if I try to move the knife in this way, what will happen? More and more pressure drag will take place because the front area will be very high. So it is also depending upon how the object is moving in the atmosphere. So we can say more is the surface area, more will be the drag. So sometimes like you do simple activity, if you take a small metal ball or you just take the bulb, let it fall down from any height, it will take some time to come on the ground. And if you take a big balloon, so if you take the balloon and fill it with the air, then it will take very long time to come down, because once you fill the air in the balloon, then the area will be very high, surface area, and it will have more and more friction on the surface. So that is how we can relate this example with the concept. So I hope this you understood. The third factor is the surface area that is in contact with the fluid, and the next factor we have is that is nature of surface of the object. So nature in the sense like, if the object is in the fluid, this surface can be rough, can be smooth. So if the surface is very smooth, what will happen? The friction will reduce. Why? Because if the surface is very smooth, then less will be the irregularities, and less will be the number of air molecules that will come into the irregularities, and then less will be the friction. So you understood, if we have this kind of object, means lots of irregularity, then lots of molecules will come within the irregularities, and if the irregularities will be higher, more will be the molecules, so more will be the friction, because overall drag depends on the number of molecules. So if you give more space to the air molecules within the object, within the irregularities, more will be the friction, because more will be the force taking place between these rest molecules and the molecules in motion. I hope you understood. But if I make this very smooth, then very less molecules will be able to come at rest because of the surface, and very less force will take place between this and the fluid. So one side you can see lots of irregularities, lots of molecules will come within the irregularities, and more will be the force between the two, because number of molecules will also decide how much is the force. More molecules, more force. But other side, if the surface is quite smooth, then what will happen? The air molecules that is coming, they are coming at rest, will be very less, because they will not get much space within the object to come at rest. Okay, so you understood, less will be the molecules coming at rest, less will be the force, and less will be the drag. So we can say smooth object or smooth surface will have less drag as compared to rough surface. So I hope you understood. So these are the main four factors we have that will basically decide the drag will be high or less. So for today, that is the only thing we are going to discuss. That is over today, and next class we are also going to discuss, if we are having the drag in the fluid, then how to reduce the drag. So what are the different methods by which we can reduce the drag, and that will be totally done based on whatever concepts we have done today. So if you have understood what are the different factors which will decide the drag, so we can also find out the methods by which we can reduce the drag. That we'll discuss in the next class. So for today is done. The only thing is, if you have any doubts, just write down. We can discuss in the live session. So thank you. Hari Om.